Good morning, students. Can you hear me? Am I audible to you? Okay, so am I audible to you? So we'll continue the session. If yes, please respond. Okay, so see here, we'll continue. So if you recall last class, in the morning we have power interruption and we couldn't continue the class, so we'll finish off the things now. Of course, this chapter won't get finished today because we lost the morning session today, so it happened. It's okay. So we'll see till what moment this chapter gets completed today, and we'll plan accordingly. So see here. So in yesterday's class, if you see, we have stopped somewhere here. We have discussed the iteration formula for the Newton-raphson method using the Taylor series expansion up to linear approximation, and then we have generated this iterative formula for this Newton-raphson method. Okay, and we then defined some condition for the convergence of this Newton-raphson method. So now, if you see, by Newton-raphson method, we have xk plus 1 is equal to xk minus f of xk divided by f dash of xk. Correct? This is what we got here by Newton-raphson method. If you see here, this is the expression that we got. Xk plus 1 is equal to xk minus f of xk divided by f dash of xk for the iteration. Now, if this is the formula, look, if xk minus 1, xk plus 1 are 3 consecutive points on a curve, for example, 3 consecutive values of x, can I write f dash of xk as f of xk minus f of xk minus 1 divided by xk minus xk minus 1. Can we write this? This is nothing but dy by dx at x. See, basically, if you see, there are 3 types of differences which you can take. Generally, if you have any curve, something like this, this is the point xk, and for example, if this is the point xk plus 1, and if this is xk minus 1, and let us suppose the change between all these three is very small, which means all these 3 points xk minus 1, xk and xk plus 1 are very small, and of course this value is f of xk minus 1, and this value is f of xk, and this value here is f of xk plus 1. So if you see these are very close, then we can write the derivative of this function y is equal to f of x at this point xk in 3 ways. See here, dy by dx at xk is equal to f dash of xk. If you write this, you can write this as, see, taking these 2 points, we can frame one differentiation, which is f of xk plus 1 minus f of xk divided by xk plus 1 minus xk, and this is called forward difference. Forward difference. Okay, because I told you derivative is nothing but rate of change of function with respect to x. So if I take f of xk plus 1 divided by f of xk, then this this portion, this change in y is very small, and we can write this as f of xk plus 1 minus f of xk divided by xk plus 1 minus xk, and this is called forward difference because we will consider the point which is ahead of this xk. Means if this is xk, we will consider one point which is forward to this f of xk plus 1. Similarly, if you want to write backward difference, you can write f dash of xk is equal to f of xk minus f of xk minus 1 divided by xk minus 1. This is what you have. Okay, so this is backward difference because with respect to the given point, we will consider the next point which is behind of it, and which is called backward difference. And there is one more thing which is called central difference. Central difference, for which this f dash of xk can be written as f of xk plus 1 minus f of xk minus 1 divided by xk plus 1 minus xk minus 1. So if you see, these are just differences, and when this difference is very small, you can write this as limit x plus 1 tends to xk, limit xk tends to xk minus 1, and all these things. And these are basically 3 types of differences that we have to find derivative at any point. And in this formula, if I write this backward difference, for example, This is what we have. Backward difference implies f dash of xk is equal to this. Now, in place of this f dash of xk, if you substitute this formulation, then we'll be getting xk plus 1 is equal to xk minus f of xk divided by, in terms of this f dash of xk, we'll be putting, in terms of this f dash of xk, we'll go for f of xk minus f of xk minus 1 divided by xk minus 1. So this is what you have. So since this is the denominator, you can multiply this. I want to bring you an iteration formula. So xk minus f of xk into xk minus 1 divided by f of xk minus f of xk minus 1. Okay, there is nothing big in this. Just we are writing this f dash of x using this backward difference formulation, and we are simplifying the things. Just algebraic simplifications you can take care of. So if you take LCM on the left hand side, basically on the right hand side, xk plus 1 is equal to, now if you multiply this complete term with this xk, see, when you are multiplying here, xk into f of xk minus xk into f of xk will get cancelled. Correct? So we have minus xk into f of xk minus 1 plus xk minus 1 into f of xk divided by f of xk minus f of xk minus 1. So since we have a minus sign here and a plus here, we'll interchange these two. So if you see, xk plus 1 is equal to the same expression I am writing with this term first and this term in the following, because it has a minus sign here. So xk minus 1 into f of xk minus xk into f of xk minus 1 divided by f of xk minus f of xk minus 1. So this is a iterative, this is also a iterative formula that we have, and this formula is called secant iterative formula. If you evaluate solution for any of the equations using this method, we call that method as secant method basically. So this is secant iterative formula. Okay, and this method is called basically secant method, where you will be given the values of xk and xk minus 1. Means, for example, if you are given initial guess x0 and x1, then you can go for x2. Once you know x2, by using x1 and x2, you will go for the next iteration, which is x3. So this is how this will proceed in this iterative formula, and this is for secant method. Okay, so these are the 4 methods that we thought of discussing: regular falsy method, and then regular falsy method, then bisection method, Newton-raphson method, and secant method, which we discussed here. Okay, so now, okay, let's not go till that moment. So see here. Before going to this, I would like to tell you one thing, which is called fixed point iteration method. Fixed point iteration method. We'll see what is this fixed point iteration method. What is this fixed point iteration method? So see here. If f of x is equal to 0 is an equation, then f of x is equal to 0 can be identically expressed as g of x is equal to x. Means, for example, if you have any function like x into e power minus x is equal to 0, if you want the solution of this value, you can write this as x is equal to e power x. Correct? Is equal to 1. For example, if you have here, if you want the solution of this equation, x into e power minus x is equal to 1, then this equation can be written as x is equal to e power x, and this can also be written as x e power x minus 1 is equal to 0, which is f of x is equal to 0. So any function f of x is equal to 0 can be written in this form: g of x is equal to x. It's like taking one x common and writing the whole expression on the other side. So if you convert this f of x is equal to 0 in this form, then The iterative formula and the iterative formula for fixed point iteration method, fixed point iteration method, fixed point iteration method is given by G, or you can write maybe xk plus 1 is equal to G of xk. So once you make initial guess x naught, assume x naught as initial guess. Assume x naught as initial guess. So if you assume this x naught as initial guess, first of all, you will get G of x naught, which means you got the value of x1. Again, if you put x1 here, you will get x2 value. So this iteration keep on repeating. And what's the meaning of this? Let us see. 0 x G of x. Okay, so see here. This combination f of x is equal to 0 can be written as G of x is equal to x. So now see here. Okay, let us write this as y, for example, for the time being. Now see here carefully. What's the geometrical meaning of this? Let us try to see. If you see, these are two curves. G of x is one curve and x is another curve. So we have two curves in this. Y is equal to x and y is equal to G of x. And we need to look for the point of intersection of these two curves, correct? So first of all, let us suppose we have done y is equal to x. Okay, so now let us suppose there is some curve, something like this, y is equal to G of x, some random curve. I am just drawing one thing, and this is the point of intersection where x and G of x values are same, correct? So this is x star, actual solution. Actual solution of the equation. This is the point where x is equal to G of x. Correct? Because if you see this on this line, y is equal to x. So if you equate both the y's, you have x is equal to G of x as this value. And this is x star, the actual solution where these are meeting. So now what you will do as per this theorem or as per this result, first of all, you will assume an initial guess x naught. And you will calculate this G of x naught value. Correct? You will assume some x naught and you will calculate this G of x naught value. Now, once you calculate this G of x naught value, you will take this G of x naught as x1. Okay, so since xk plus 1 is equal to G of xk, if you are taking x naught as initial guess, G of x naught, if you put k is equal to 0, then G of x naught is equal to x0 plus 1, which is x1. So this difference, which is initially here, you will take here this time. So if you equate this length with this length, somewhere here, this x1 appears to us. Something here. So again, if you take this, we'll be getting some x2. So in such way, we'll be approaching this solution. Okay. So finally, we'll achieve this point where this happens. But now, one thing we should take care of is, for the solution to be convergent means for this iterative method to converge to a solution, for the solution to be convergent, the only condition is modulus of g dash of x should be less than 1. Okay, because g dash of x is generally changing this y values with respect to x values, and the system can converge only if the change in y is less when compared to the change in x. Okay, so this is the way you can write this solution. And because I'll tell you, for any given f of x, you can't form a unique g of x generally. For example, if I write x minus tan inverse x is equal to 0, then you can write x is equal to tan inverse x. Similarly, if you shift this tan inverse to the other side, we can write x is equal to tan x. So there can be multiple functions. But as long as this condition gets satisfied for g of x, the solution definitely will converge. Okay. For example, here you can write x is equal to tan x as well, if you shift onto the other side. So if you see, they can exist multiple number of g of x's for any given function f of x. But as long as your choice of g of x is satisfying this condition, your solution definitely will converge. Okay. Now, we'll discuss one important thing called rate of convergence. convergence. Oh, this is also called order of convergence. Order of convergence. So let us see the difference between these two. I mean, sorry, both are same thing actually. Let us see what's the definition of this. Okay, so weight of convergence. If f of x is equal to 0 is an equation, any equation, algebraic or transcendental, doesn't matter, is an equation, and alpha is the actual real root of the equation. Actual real root of f of x is equal to 0, and xk plus 1 comma xk are the values obtained by, I'll tell you what's the use of convergence. See here, by looking at the definition you will understand yourself, so that's why I'm writing this. And xk plus 1 comma xk are the values obtained by using iteration formulas in k plus 1th and kth iterations, in k plus 1th and kth iterations. See, definitely if I given f of x, if you use any of these methods, you have different iteration formulas, so you can calculate xk plus 1 and xk when initial guesses are given to us. Then if e k plus 1, epsilon k plus 1 is nothing but alpha, or you can write maybe xk plus 1 is equal to alpha plus epsilon k plus 1, because iterations only give approximated results but they don't give exact results. There will be small change between the exact root and the value that you obtained in the k plus 1 iteration. That's why if you see in yesterday's class, I have substituted this, I have put this approximation sign but not an equal to sign, correct? But then we assumed that after k is very large they will be equal. So see here, if xk plus 1 is equal to alpha plus ek plus 1 and xk is equal to alpha plus ek, where ek plus 1 is the difference between these two values, xk plus 1 and alpha, and ek is the difference between xk and alpha. Okay, and these two need not be same, but they'll be very small and close as well. So if you see, then we say a real number in bracket largest possible real number. We say a real number in bracket largest possible number p as a rate of convergence, of the method, if ek plus 1 can be written as some function, some constant into ek power p plus order of terms containing ek minus 1, ek minus 2 and so on, like this, which are we neglect in the Taylor series expansions and all these things. So this number p is called as order or rate of convergence. Okay, rate of convergence. So one thing I want to tell you now, if this order of these small terms if we neglect, which means if ek plus 1 can be written as a into ek power p plus, I'm neglecting these terms, so plus some small value, then we are calling this p as the rate of convergence. Now, what's the physical meaning of this rate of convergence? See, definitely after some finite number of iterations, this value will be very small, correct? Which is of course less than 1, but still it is very small. Now, if p is more, look carefully, answer my question very carefully. If a is a constant, then please tell me ek is anyhow small, we know this. If p is more, what happens to the value of ek plus 1? Will it be more or less? If p is more and if this value is less than 1, then tell me this value will be less or more. If P is more, when Ek is less than 1, this implies Ek plus 1 will be less. Correct? See, because if you write 0.5 whole square, this is 0.25. But now if you go for 0.5 whole cube, then answer would be 0.125, which is smaller when compared to this. Correct? Always less. Now see carefully. If P is more, then we yourself told Ek plus 1 is less. Correct? If Ek plus 1 is less, which means if Ek plus 1 is less, what about the relation between these two? Xk plus 1 is very close to alpha. Correct? If Ek plus 1 is less, as you have told now, if Ek plus 1 is less, which means this difference or this term will be very small. If this term is very small, this xk plus 1 is almost equal to alpha, which means in the iteration values, we'll take this real root same as the value that you obtained in xk plus 1 iteration, which means one thing it's very clear for us, to minimize the number of iterations, this P should be more. Correct? Because when Ek plus 1 is very small, you know, this alpha will be almost equal to xk plus 1, means if you want to attain the solution in a very less number of iterations, this value of P has to be more, because it will make the change less within less number of iterations. Clear to all of you? Did you all understand this? For the method to converge faster, this P has to be more, because if this P has to be more, definitely this change will be less. So now this is the definition of rate of convergence. And one thing, for faster convergence of any iterative method, for faster convergence of any iterative method, rate of convergence has to be high. Rate of convergence has to be high, or you can say has to be more in general. So now actually I thought of showing you this rate of convergence for this Newton-raphson method, but because of time constraint today, unfortunately something happened, so I could give you the values. Okay, so please consider this as a rate of convergence of different methods. Okay, so please try to take this method and rate of convergence, means basically this P value which we can write. We have formulas we can derive. I will give you the idea how to derive, but I won't derive because time is very less now. So I won't derive, but I'll give you the idea how we'll be getting different values of P. Okay, method. First method, a regular falsy method. A regular falsy method is linear convergence method. Linear convergence, and we'll get P is equal to 1. Okay, generally 1 is called linear, so a rate of convergence, the order of convergence is 1. So if order is 1, we'll call it as linear. So this is what. Second, for bisection method. Bisection method is also linear convergence. Bisection method is also of linear convergence. Again, P value is 1. 3. Newton-raphson method. Newton-raphson method. The convergence is 2, and we call this as quadratic convergence. Quadratic convergence, and P is equal to 2. Fourth, if you go for secant method for which we have derived this iterative formula using Newton-raphson method, if you go there, then the convergence is 1 point, or you can write P is equal to 1.618, which is approximately equal to 1.62. Okay, so all these values look something better because they are integers, but this is P is equal to 1.618. Actually, when you are performing this analysis, you will be getting something like Ek plus 1 is equal to A into Ek power P, which is same as ek power 1 plus 1 by p. This is what you will be getting when you are finding the secant method, trying to derive expression for rate of convergence of the secant method. So if you equate these two, when bases are equal, this power should be same. So p is equal to 1 plus 1 by p is what you will do for secant method. And if this is a quadratic equation, p square minus p minus 1 is equal to 0. So p is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. Okay, but if you take this positive value and if you take this negative value, rate of convergence can't be negative. Correct? If rate of convergence is negative, then what happens? This change, it increases as it goes on, means the solution doesn't converge to a single point. Correct? See, for example, here if this p is negative, then what happens? See, 0.5 whole power minus 1. If I have minus 1 as a rate of convergence, then this value is 2. Correct? Yes or no? So if this p is more, then this ek plus 1 will actually increase than ek, which means xk plus 1 is far away from alpha when compared to xk, which means solution is diverging. So we can't have negative values of p, and when you simplify this expression, this value is nothing but, this value is nothing but 1.618. And during the derivation of this rate of convergence of secant method, we'll be ending up with something like this, with which when you equate the exponents p is equal to 1 plus 1 by p, you will be getting this 1.618 from here. Actually, we don't have time, otherwise I thought of showing you by complete derivation, but it happened unfortunately. Okay, so anyhow, proofs are not important for gate, but these values for fixed point iteration method, we don't have any particular standard to tell rate of convergence for that. And of course, people call it as linear in general. Okay, but these are the 4 methods that are really important for us to talk about this rate of convergence. Okay, so I'll show you the methodology how to calculate, but we may not go till the last step because it's time consuming. So for Newton-raphson method, I'll show you simply. For Newton-raphson method, what do we have? Xk plus 1 is equal to xk plus, minus f of xk divided by f dash of xk. Correct? This is the iterative formula we have. Now, if you see, this xk plus 1 can be written as ek plus 1 plus alpha, and this xk can be written as ek plus alpha minus f of xk can be written as ek plus alpha divided by, this is also f dash of ek plus alpha. So now if you see, this alpha gets cancelled. This implies ek plus 1 is equal to ek minus, if you expand this function using Taylor series, f of x plus h, because this ek is small when compared to this alpha, because this ek is the difference between the iterative value and the exact root. So this can be written as f of alpha plus ek into f dash of alpha plus ek square by 2 into f double dash of alpha, and of course we are stopping it here because this f dash of alpha is sufficiently enough to calculate the things, divided by, again we have f dash of alpha plus ek into f double dash of alpha by 2. Again we are applying Taylor series for this, because if you have the function f dash of alpha plus ek, then functional value f dash of alpha plus h into f dash of x, and f dash of this f dash of alpha is f double dash of alpha, and so on. We'd go for things like this. Okay, so now if you see, this f of alpha is 0. Why this f of alpha is 0? Because alpha is exact root of this f of x is equal to 0. So if alpha is exact root of f of x is equal to 0, then this f of alpha will be definitely 0. Okay, so now if you take f dash of alpha and one ek common from all these things, ek plus 1 is equal to ek minus, if you take ek common, ek into f dash of alpha, if you take it common, we have ek into f dash of alpha, if you take it common, 1 plus ek by 2 into f double dash of alpha divided by f dash of alpha. Correct? Here in the denominator as well, if you take f dash of alpha common, see carefully, I am doing it, f dash of alpha, if you take it common, you have 1 plus ek by 2 into f double dash of alpha divided by f dash of alpha. This is what you will be having. You can cancel this f dash of alpha and f dash of alpha here, and you can write ek plus 1 is equal to ek minus ek of 1 plus ek by 2 into f double dash of alpha divided by f of alpha, f dash of alpha into this term. If I shift it onto the top, 1 plus ek by 2 into f double dash of alpha divided by f dash of alpha whole power minus 1. This is what we have, correct? Because this is 1 plus ek by 2 into f double dash of alpha divided by f of alpha. So if you want to multiply this here, we'll write a minus 1 sign there. So ek plus 1 is equal to ek minus ek into 1 plus ek by 2 into f double dash of alpha by f dash of alpha. When you multiply this into this expansion, if you write 1 minus ek by 2 into f double dash of alpha plus f dash of alpha, neglecting higher terms of ek square and all again here, this will give us something like ek plus 1 is equal to, see, if you multiply this, there will be one ek and this ek cancels this, correct? And finally the thing that we'll be ending up with is, minus into minus plus, so 1 by 2 into, correct, 1 by 2 into f dash of alpha, if you take common, there is 2 here, correct? So 1 by 4, I guess, correct? If you multiply these two, 1 by 4 into ek square by 2, I mean this 2 is already taken care here, so f double dash of alpha divided by f dash of alpha, so plus some order of higher terms which we don't consider generally, higher order terms. So if you take ek plus 1 is equal to some constant f double dash of alpha divided by this, which is purely a constant because alpha is already a constant. So if you see, you can calculate these two values into ek square plus some order of higher terms. And so if you compare this with the rate of convergence definition that I told you, we have 2 here. Okay, so that's why this order of convergence of this Newton-raphson method is 2, but this is the procedure that we need to carry out for this. So anyhow in GATE exam they don't ask you, but just rather than giving all these values randomly to you, I thought of showing at least one for you, okay, because time is short. Otherwise for secant method I could have shown you why this is 1.618 basically. Okay, so if you compare for Newton-raphson method 2, now with your experience of rate of convergence definition, please tell me. Yeah, I think there could be some calculation mistake here. This will be 2 actually. Okay, so this should be 2 in general. Okay, so that's why ek terms gets cancelled and we'll be having ek square this. Yeah, how we expanded using Taylor series. In basic calculus we have this Taylor series expansion, f of x plus h into f dash of x divided by 1 factorial plus h square into f double dash of x divided by 2 factorial and all these things. So basically on this expansion, I have expanded this f of alpha plus ek as f of alpha plus ek into f dash of alpha plus ek square by all these things. Okay, so when you cancel, see, first derivatives we can cancel, but there will be second derivative terms here. See, minus ek square by 2 minus ek by 2 and all. So we have 1 by 2 into f double dash of alpha divided by f dash of alpha term here. Okay, so that's why we couldn't take this. Okay, so whatever the calculations are involved, you please do them carefully. You will be getting something like this. Okay, because the rate of convergence of this method is 2. If there is some calculation error here with plus and minus, you please do that carefully. You will be getting this expression finally. Okay, so now if we go back, so now tell me, out of all these methods, for any given equation f of x is equal to 0, for any given equation f of x is equal to 0, now tell me, out of all these methods, which method will converge faster? If you have all these 4 methods, generally if you see the rate of convergences, you have 1, 1, 2 and 1.62. So out of all these methods, what's the method that with highest rate of convergence? Third, Newton-raphson method, correct? So that's why Newton-raphson method is very important, and also in GATE examination they put a lot of questions on this, because for any given question this Newton-raphson provides the solution within less number of iterations. Okay, so that's the reason why, to save your time, because calculations in iteration methods are very huge actually. You need a lot of decimals and different things here, so they generally ask you for Newton-raphson method because convergence rate is higher here. Okay. This just to show you, this 2 comes here. I have done all these things, but practically for GATE there is no necessity of this. You can, it's fine as long as you understand this. One more thing I would like to tell you, in bisection method, the minimum number of iterations required, to have an iteration value, xk, means in the kth iteration, such that xk minus alpha is less than epsilon. You can take modulus if you want, because this is the difference between the actual root and the value that you are obtaining in xk, where you can write, where epsilon is a constant which is very small, and alpha is the root of f of x is equal to 0 in a comma b. Because if you want to apply bisection method, you need to have an interval. We have seen in yesterday's class. So this x is equal to alpha is the actual root of this equation f of x is equal to 0 in this interval, and this xk is the value of the iteration value that you obtain by performing few iterations, by taking any or by using any of these iteration. I mean, this bisection method iterative formula is given by the equation modulus of b minus a by 2 power n is less than epsilon or equal to epsilon. So this is what the n is, the minimum number of iterations you need, to get this solution xk in the kth iteration, such that the difference between this is less than epsilon. So generally, if you keep on going for these iterative methods, there comes small difference between the actual root and the iterative formula obtained. But there are some permissible limits, and this epsilon is decided by you. Okay? Up to which accuracy you need the root. If you don't define this, the iteration goes on, because in every iterated value, after every 3 decimal points, 4th decimal may change, and after some iterations, 5th decimal may change, and all these things. So if this is the equation, means if you want the value of x within this range of alpha, then this is the number of iterations you need to perform, which is given by this. This is given because, if you apply first iteration, then what happens? This interval which is a comma b get reduced to half. If you want the second iteration, then this reduced to again 1/4 of the given actual interval. So finally, the interval gets reduced by 2 power n times when you perform k iterations, or else you can write maybe k here. Because we are writing in case, so you can write k. Okay, so this is the minimum number of iterations that you need to have the solution within this range epsilon. Because what happens if you see, first if this is AB, and let us suppose alpha is somewhere here, then this is your new point C. When you apply first iteration, what happens? This interval is very much less than, half of this, which is a minus b or b minus a divided by 2. This is the size of the interval now. Now, if you go for second iteration, it again gets 1/4 of this. So we'll go for 2. So like this, if you perform k iterations, you'll be getting 2 power k, and finally you'll be getting your interval very small, such that it lies in the neighborhood of a. Okay. So this is the formula that we have for performing number of iterations in bisection method, that the minimum number of iterations you need to perform, so that your value in the iteration and actual root will differ by very small amount, which is less than this epsilon, which is defined by us. Okay, so we have put some questions now. We'll see different questions on this algebraic equations, basically algebraic as well as transcendental equations. So please see here. Let us try to solve these questions. Solutions. The iteration formula to find the square root of a positive real number b means you want the value of x is equal to square root of b by using Newton-raphson method. So you want to find the value of this x where x is equal to square root of b using Newton-raphson method. So what's the iterative formula for this? So if you see, this function can be written as x square minus b is equal to 0. Correct? Because if you square this equation on both sides, we have x square is equal to b and x square minus b is equal to 0, and we have f of x is equal to 0. Now you can apply the iteration formula and please try to tell me the answer. Xk plus 1 is equal to, I will be doing along with you, so please you also try. We have xk minus f of xk divided by f dash of xk. So this implies xk plus 1 is equal to xk minus f of xk. If this is f of x, which is x square minus b, f of xk is xk square minus b divided by f dash of x. You know, if x square minus b is f of x, this implies f dash of x is equal to 2x. So this f dash of xk is 2 times of xk. Okay? So if you simplify the things now, xk plus 1 is equal to, if you take LCM, xk into 2xk is 2xk square minus xk square will give you xk square, minus into this minus will give you plus b divided by 2xk. And this is the iteration formula to find the square root of this number, which is given in option B. Okay, so in exam, I'll tell you one thing. When such kind of questions are given, there is one technique if you forget this formula, because many times we'll be seeing terms like this. F dash of x by f of x means generally numerator of lesser degree. Correct? We have this intuition in our mind, and we'll apply this formula in a reverse way, which will change our answer actually in exam. Correct? Because many times you'll be seeing this kind of terms, because this degree of this f dash of x will be less when compared to f of x practically. So we generally have an intuition that lesser degree term comes in the numerator and higher degree term comes in the denominator. But this is the correct formula. So in exam, if you get confusion between these two, now you remember, of course, this is f of xk divided by f dash of xk. But if you have a confusion, then go for one thing. Okay, don't go for random guess, but you can still go for one thing. Now, see, when k is very large, when number of iterations are very more, then tell me what's the value, what's the difference between this xk plus 1 and xk? After some finite number of large iterations, this xk plus 1 and xk will be almost, please tell me, after some finite number of iterations, this xk plus 1 and this xk will be almost same. Correct? So xk plus 1 will be almost equal to xk. Correct? So in the given 4 options, if you forget this formula, f of x by xk, or means f by f dash or f dash by f, if you have some ambiguity, you can go for one thing. In all the 4 options, wherever there is xk plus 1, put xk. Okay, so if you put xk here, xk is equal to 3 times of xk plus b by 2xk. So if you simplify the things, 2xk square is equal to 3x plus b minus 3xk minus 3b is equal to 0. Is this the given equation? Is this same as this equation? 2x square minus 3x minus 3b is equal to 0. Are these two equations same? Please respond. If you put xk is equal to xk plus 1 is equal to xk, and if you simplify, is this the equation which is same as this? No. Now let us go for next option. If you put xk here, if you multiply these two, 2xk square is equal to xk square plus b. So you can cancel one xk square here. So the final answer is xk square minus b is equal to 0. Now, are these two equations same? Now, are these two equations same? Xk square minus b and x square minus b. Again, if you check for this, you won't get this equation x square minus b, and for this also you won't get this equation x square minus b. Means if you have a doubt whether it's f by f dash or f dash by f, then simply do one thing. In the all 4 options, wherever there is xk plus 1, put xk and simplify the equations. Out of all these 4 options, one option will give you the actual question equation. Okay, and that's the solution of that. Okay, it's simply logical, because when k is sufficiently large, these two values are almost same. So you can replace xk plus 1 with xk. So if you replace xk plus 1 with xk, and if you simplify all the 4 options, out of these 4 options, one option will definitely match with the given equation in the question. Okay, but this is useful only if they are asking you iteration formulas. If they give you some initial guess, and if they're asking you for x1, x2 other values, then you can't use this, obviously, because with the initial guess, you need to calculate values manually. Okay, so is that understandable to all of you? How to check options if questions are of this particular kind? Please respond. Did you all understand how to identify the option if questions are of this particular kind? If you forget this formula, clear to all of you? I want all of you to respond. I want some 46, I guess. Yeah. Okay, so we are going for next question. So please solve this. In the interval 0 to pi, the equation x is equal to cos x has, this is the case. So please try to solve this question, all of you. I'm giving you some time. So please solve this. B, exactly one solution, Kamaluddin. Let me check. Meanwhile, you other people do. B is the correct answer. Okay. So simple. When these are given, we can draw the graphs actually. Minus x, y, x, and minus y. Here he is not asking for the solution. He is asking for number of solutions, correct? Which means we need not solve this equation, correct? Because he is just asking for number of solutions, but he is not asking for the solution. So now, first curve, y is equal to x. Let us try to draw that curve. Y is equal to x. Since we are having only 0 to pi, I am not drawing it on the left hand side. So we are stopping here because 0 to pi. Let us suppose pi is somewhere here. Okay, so now this is the line x is equal to pi, and of course this is the line x is equal to 0, and we want to talk the nature between these two. So see here, if you draw the graph y is equal to cos x, you know, if this is pi, this is also pi, which means pi by 2 is somewhere here, and you know, at pi by 2, if this is the value, cos 90 is 0. So if you see, and if this is minus 1, you know, cos x graph will look something like this between 0 to pi, correct? Because this is pi by 2 is 1.557, but cos 0 is only 1. This value is 1 and this is 1.57. Okay, so this is cos x graph between 0 and pi. Now if you see, there is one point of intersection between this y is equal to x and y is equal to cos x, correct? So there is one point of intersection between, for the curves y is equal to x and y is equal to cos x, means there exists only one value of x where this x is same as this cos x. Okay, simple. Try to draw two graphs. You know, graph of cos x is something like this, correct? Of course, this is 0, this is x is equal to pi by 2, and this is x is equal to pi. So I have reproduced this part of cos x from 0 to pi here. Okay, because the interval given is 0 to pi. So if you create this graph from 0 to pi and you can plot y is equal to x. So if you see between 0 and pi, these two curves are intersecting and only at one point. So we say we have only exactly one solution. Clear? This is just cos x graph. I have reproduced this graph. But why I have taken this as point? Because pi by 2 value is 1.57 and maximum value of cos is only 1. So we need to put this point below this pi by 2. Okay. We have one more question with sin x. We'll see there for sin x. Okay, Shankar? Clear? So can we move ahead with this question? Did you all understand how we have only one solution exactly? All of you, did you understand how we have only one solution for f? This x is equal to cos x within this range 0 to pi. Okay, so see here. Third question. Solution. We wish to solve x square minus 2 is equal to 0 by using Newton-raphson technique. Let the initial guess be 1. Okay. Subsequent estimate of x, that is x1. So please try to solve this question, all of you. It's given, we need to find the value of square root of 2 using this iterative formula basically. So please try to do this. It's already 11:20. 50 minutes has already completed. Okay. Time is very short actually because of this internet issue. We'll see how to balance the things. B is the answer, 1.5. Okay. Option D, none of the above. But many of you are telling B. Okay, so let me show you. First of all, my sincere suggestion to all of you, whenever you are solving something in numerical methods, even if you are very good at mind calculations, but please don't do that, write iterative formula once. Okay, it doesn't matter how good you are in calculations, but please, I'm requesting you, please write iterative formula once, because during mind calculations, if your first iteration value changes, if you make a small mistake, and let us suppose this x1 is actual x1 when you apply this iterative formula neatly, and let us suppose this is some different value which you got in first iteration. Then what happens? If first iteration value is wrong, second iteration value will be wrong. Second iteration is wrong, third iteration will be value wrong. So if you see, this values which you find in iterations are very important. Okay, because if value in one of the iteration changes, every other iterations they go wrong. Okay, so my sincere request, it doesn't matter how small, how big the question is, please write iteration formulas always. So if you write iteration formulas, anyhow it's given this Newton-raphson technique. So xk plus 1 is equal to xk minus f of xk divided by f dash of xk. Okay, so xk plus 1 is equal to xk minus, for f of xk what do we have? Xk square minus 2 divided by 2xk. So if you simplify the things a bit, xk plus 1 is equal to 2xk square minus xk square, which is 1xk square plus 2 divided by 2k. This is what we have. Correct? If you write a bit correctly, you can take this 1 by 2 common, and this is not k, this is xk, sorry. So 1 by 2 into xk plus 2 by xk. This is what you will be having. Correct? So now we got the iteration formula as xk plus 1 is equal to half into xk plus 2 by xk. Normal iteration formula we got before, 1 by 2 into xk plus b by xk, if b is any number. So now given x naught is equal to 0, 1. So what happens to x1? x1 is equal to 1 by 2 into 1 plus 2 by 1, which is 3 by 2, and the answer is 1.5. Okay. Okay, along with these videos, I'll give some individual topics which I'm not dealing here. So both of them could help you, Sunil. Okay. So now, if you see this question carefully, the first option is given as 1.414. Correct? In exam, if people don't have time, they think that the square root of 2 is 1.414. Correct? X square minus 2 is equal to 0 is same as x is equal to square root of 2, for which the actual answer is 1.414. So students, instead of doing all these things, they'll go for 1.414 directly in exam, and that's why this is given in first option. But one thing, iteration methods will give actual solution after some finite number of iterations. Okay, they don't give the correct answer in the first iteration itself. Did you all understand? For example, if you see here, if you apply this Newton-raphson method, first of all we got 1.5, correct, which is not same as square root of 2. But if you perform one more iteration, you will be getting something very close to 1.4 again. But we don't get exact answers in the first, you may get for some questions, but it's not mandatory that you will get exact answers in the first iteration itself. But this is exact answer which you are not getting in the first iteration. In the question, he is asking for first iteration value. So first iteration value is 1.5, but not 1.414. Okay. So even though the exact answer is 1.414, this Newton-raphson iteration technique is not giving the exact answer in the first iteration for this particular example. X square minus 2 is equal to 0. Okay. So in exam, if you know the values, if you can find the solutions, don't write them directly. Okay. Because they may not be the answers of iterations here. Okay, clear to all of you why this 1.414 is given here, and what's the caution you need to take in exam? If you know the answers directly, don't go for that options if they are present, because iteration methods may not give the same answers in the initial iteration steps. Okay. Next, the Newton-raphson method is used to find the root of the equation f of x is equal to 0. I think here we missed it. F of x is equal to 0. Okay, and f dash of x is the derivative of f. Okay, the method converges. Pradeep, is it C? Why it should be C? A. Did you all remember? We told for convergence of Newton-raphson method, modulus of this f of x into f double dash of x should be less than mod f dash of x whole square. We learned this. Correct? Is this condition present in any of these three options? First three options. We told you this condition, correct? Newton-raphson method doesn't converge always, but for its convergence, this condition should be mandatorily, get satisfied. Did we tell this or not? For convergence of Newton-raphson method, all of you. You want me to show the slide? I think this board has a trouble again. It's buffering here. Okay, so I told you, but is this option present in any of the first three options here? See, that's what I discussed as the last point in yesterday's class, if you remember. See, the condition for convergence of Newton-raphson method. Okay, so that's why if you see, this condition is not present anywhere, so the answer is none of the above. And f of x need not be polynomial because we use Newton-raphson method even for transcendental equations, correct? We use trigonometric ratios and all these things, sin x, cos x and all. So if you see, these three need not be mandatory all the time. F of x naught can be less than 0. I mean, it can be greater than 0 as well, no problem. Okay. So the answer is none of the above. Okay, because this condition is not present in any of these first three options. Next, solution. We wish to calculate the reciprocal of A using the Newton-raphson method for f of x is equal to 0. The Newton-raphson algorithm for the function will be means which of these iteration formulas could give us the value of 1 by A. Okay, so x is equal to 1 by A. This is what we have. So please try and tell me the answer. This is for square root of 2, so this is not the answer. This is for 2 by A, this is also not the answer. I think C is the answer. Correct? Newton-raphson method converges always if this function satisfies this condition, okay, which is not given here. Okay, and of course this don't give you the answer. Yes. So now, yeah, what do you think is correct, Gayatri? So see here, we have a minus 1 by x is equal to 0. Correct? So xk plus 1 is equal to xk minus f of xk divided by f dash of xk. So if you see, xk plus 1 is equal to xk minus a into xk square plus 1 xk again. So this is xk plus 1 is equal to 2xk minus a xk square, which is the iterative formula. But one important thing is, yes, that's what I am going to tell you now. Why I have not taken x minus 1 by a is equal to 0? This could be the question to all of you. Correct? I have taken a minus 1 by x is equal to 0, but I didn't take x minus 1 by a is equal to 0. What happens if we take this as the function? See now. See what happens. If you write iterative formula, xk plus 1 is equal to xk minus f of xk divided by f dash of xk, 1, which implies xk plus 1 is equal to xk gets cancelled and you will be having 1 by a. That's it. We don't have, means basically it doesn't produce any iterative formula for us. With the initial guess, we can't succeed through iterations if we take the question in this way. Okay, so that's why we have modified the equation in this way, because our main intuition is to develop some iterative scheme or iterative algorithm for the procedure. Okay, but if you do it this way, we don't be getting any algorithm for any initial guess. It just tells us the final value is 1 by a. Okay. Okay, someone asked me, I forgot his name. It's not here. Okay, so did you understand why we have taken a minus 1 by x is equal to 0? Okay, Uganda. So see here, this is next question. For a is equal to 7 and starting with x naught is equal to 2 in previous problem. Okay, in previous problem, given x naught is equal to 2, and what about x is actually 1 by a is the equation. Okay, in previous problem the first two iterations will be, means if x naught is equal to 2, what about x1 and x2? This is the question he is asking for. Okay, so if you see, we got xk plus 1 is equal to 2xk minus axk square as the iteration formula. Correct. So now this implies x1 is equal to 2x0 minus ax0 square. So x0 value is 2, so 2 into 2 minus a value is 7, so 7 into 2 square, which is equal to 4 minus 28, which is minus 24. Oh my god, something changing here, but answers are given in 0.11 and all. So please try to solve this. Two into 2 minus 7 into 2 square. 4 minus, make one correction, make this as 0.2. I think it should be 0.2 because values are close to that. So make that 0.2. Okay, otherwise values will diverge anyhow. So I think in this question it's 0.2, but there is some mistake while writing this question. So make that 0.2 and calculate the values. Two into 0.2 minus 7 into 0.2 whole square. 2 into 0.2 is 0.4 minus 7 into 0.04. So 0.4 minus 0.28. So 0.40 minus 0.28 will give you 0.12. But two options are here. So this is wrong and this is also wrong because there are two options with 0.12. So you got x1 as 0.12. Next, calculate x2, which is 2 times of 0.12 minus 7 times of 0.12 whole square. So calculate this. 0.24 into, acha, you can't take 0.14 common, you can take 0.12 common. 2 minus 7 into 84, so 0.84, which is 0.12 into 1.16. 2 6 are 12, so last number should be 2 and it's here. So this is the answer. Okay, because when you multiply these two, 2 6 are 12, so units digit will be 2 before, I mean after the decimals. So here there is 2, so this is the answer. Okay, 0.139. Okay, because if you multiply these two numbers, the first digit has to be 2 here. 2 6 are 12 and here it's 6, so 2 is the correct answer. Okay, since options are given to us. Or else if you want, you can use calculator for determining all these things. Okay, clear? We can use calculator as well to calculate these values. Anyhow, for the time being, we are not using that. Solution for this 7th question. The real root of the equation x into e power x is equal to 2 is evaluated using Newton-raphson technique. If x0 is equal to 0.8676, oh my god, some 4 this thing is given. The second approximation value of x corrected to 3 decimal places is dash. So what is f of x is equal to 0 implies x into e power x minus 2 is equal to 0. So if you apply Newton-raphson iteration scheme, I told you, even though they are asking for the first iteration, but please, calculate this value. Write iteration formula first. Xk minus f of xk is xk into e power xk minus 2 divided by f dash of xk. So f dash of this is xk into differentiation of this is e power xk plus e power xk into 1 minus 2, it's 0. So this is the iteration formula that we have. So if you multiply the things, xk square into e power xk plus xk into e power xk minus xk into e power xk, they'll get cancelled. Minus into minus plus 2 into e power xk, if you take common, you will be having xk plus 1. So if you want, you can cancel this xk's here and you can write e power minus xk here. Okay. So you can write the iterative scheme as xk plus 1 is equal to xk square plus 2 times of e power minus xk divided by xk plus 1. So this is iterative scheme that is with us. So now we'll go for finding second approximation value. Means x2, basically he's asking for x2, second approximation. So x1 is equal to x0 square plus 2 into e power minus x0 divided by x0 plus 1. So let us calculate this value using virtual calculator. And x0 value is 0.8676. Correct? 0.8527. Okay. Let us see. Let me show you some virtual calculator applications, because in numerical methods, this application of virtual calculator is really important because you need to perform a lot of calculations. So see here. What are the terms we have? x0 square plus 2 into e power minus x0. x0 square plus 2 into e power minus x0. So see here. 0.8676 is the value, correct? x0 value, first of all. 0.8676. Now you want square of this plus 2 times of e power minus of this. So x0 square plus 2 into e power minus x0. x0 square, first of all, see, I'll tell you some key points in this calculator. So please listen, don't write anything, I'll give you time. This MS stands for memory storage. Means if I want to store this, see, here there is nothing now, correct? But if I click MS, you see there is M here, which means there is one data that got stored in the memory of this calculator, and the memory value we stored is 0.86. Okay, so if you cancel this MR stands for memory recall. If there is something in the memory, we'll call that here. So if I click MR, you see 0.8676 came here. If I click MC, then memory clears, and you can see this M got vanished here. Correct? So this is what we can have. So 0.8676, I am storing it for some purpose. Next, so square of this plus 2 times of e power minus x, correct? Plus 2 times of minus x. So 2 times of minus x into exponential. So this gives me square root of 0.8676 plus 2 times of e power minus 0.8676, whose value is 1.592, divided by x0 plus 1. So memory recall plus 1. This is by x0 plus 1, and if you calculate, the value is 0.85277. Correct? So this value of iteration is 0.85277. When you calculate it, this x0 is equal to 0.8676. Okay, so this x1 is 0.85227. Sorry, 277. 0.85277. Okay, next, if you go for x2, x2 is nothing but x1 square plus 2 into e power minus x1 divided by x1 plus 1. You want to calculate this value, where x1 is this. Again, go to the calculator. Now, if you click MS again, now this stores this 0.85277 as memory value. So see here, I am clicking MS. So if I cancel, if I click MR, you see this 0.85277 is stored in the memory again. Okay. So now you want this square plus 2 times of minus this value to this exponent. So you can see square of this value plus 2 into e power minus this value. Okay. So if you see, this is the value divided by memory recall plus 1, 0.8526. 0.8526. Correct? So if you round off to 3 decimal places, this value is 0.853. Okay, so you need to be careful with virtual calculator when you are putting brackets. Okay, see, for example, here, if I don't put this bracket here, then you know what happens? The value that you'll be getting is more than 1, because this is divided by this. So something will be more than 1 will come, plus this 1 will add to that value. So placing these brackets is really important, and you should know this memory storage, memory recall, and memory clear. So if I say my purpose is finished, so we can click memory clear. So you see this m which is initially here got disappeared, cancel, 0. Okay, so now after doing every question, please do this, because instead of clicking some 7 or 8, if your mouse moves to MR or MS, then what happens? The value which is here will comes into the calculation and disturbs your total value. Okay, so after completion of every question, if you are using this button, please clear the memory. Okay, this is my sincere suggestion to all of you. So did you all understand this part? How it's 0.853? Because calculations play a very important role in GATE exam, and that's why in my class I show some calculations here. The difference between All India first rank and All India 150 rank is only this calculator. Please trust me. Okay, I'm telling you, because of calculation mistakes, every year many students, they lose everything. Okay, which they deserve actually. So please practice this calculator as much as you can. So we'll work out a few more questions. Okay, so clear to all of you? So see this solution. The bisection method is applied to compute a root of the function f of x is equal to this function in the interval 1 to 9. The method converges to a solution after how many iterations? So this is what we have. So if for the first iteration, the x1 value is a plus b by 2, 1 plus 9 divided by 2, which is 5. Okay? So what is f of x1? It means f of 5. If you see carefully, first of all, let us calculate f of 1. If you want f of 1, 1 minus 1, 0, 0 minus 1. Minus 1, minus 1 minus 4, it's minus 5. And f of 9, if you see f of 9, 9 power 4, 81 into 81. Okay, let us use calculator for this. Again, some cubic expression. So 9 power 4 minus 9 cube. Okay, minus 9 cube minus 9 square minus 4. So minus 85 totally. This is value of, total value, right? 9 power 4 minus 9 cube, which is 721, actually 729. 729 minus 9 square, 81 minus 4. So total 5747 is the value here, which is positive. And this is negative. And you know, this function is a polynomial function, so it's continuous everywhere. So now, if you go for this, f of x1 value, f of x1 is equal to f of 5. So this is equal to f of 5 value, if you calculate again, 5 power 4, it's 625 minus 125 minus 25 minus 4. And this value is 471. So if you see, this value is 471, which is greater than 0. So root lies between 5 and 1, correct? So x2 is equal to 1 plus 5 by 2, which is 3. So if you calculate f of 3 again, 3 power 4, 81 minus 3 cube, 27 minus 3 square, 9 minus 4 is 13. So 81 minus 40, 81 minus 40 will give you 41. So this is also positive again. So f of 3 is positive, which means basically, if see here, initially the solution is 1 comma 9 and we got the mean value as 5. So if you see, these two are opposite in signs, but this f of 5 is greater than 0, which means root lies in 1 comma 5. Now when you performed 1 comma 5, you got 3, and for 1 this is less than 0, for 5 it is greater than 0, f of 3 also greater than 0, which means if you see, the root lies in 1 comma 3. Correct? Root lies in 1 comma 3. So x3 is equal to 1 plus 3 by 2, which is 2. This is what you have. Correct? 4 by 2, 2. So 2 power 4 is 16. 16 minus 8, 8. 8 minus 4, 4. 4 minus 4, 0. Which means f of 2 is equal to 0. And this is satisfying the equation. So this x3 is equal to 2, which you obtained in the third iteration, is the solution for this equation. So we need total 3 iterations to calculate the actual root of the equation. Okay. Simple question, just bisection method applying for 3 iterations. I told you, depending upon the signs, you need to check whether the next interval is 1 to 5 or 5 to 9. So simply based on the signs, I have checked it. Just bisection method. So in bisection method, how will you calculate the iteration value? X1 is average of the interval values. So 1 plus 9 by 2, we got 5, and we calculated f of 5. Now, if you see, I told you, if f of a into f of c is less than 0, consider the interval as a comma c. If f of a into f of c is greater than 0, consider the interval as b comma c. This is what I told you. Correct? So now, if you see here, f of c into f of a is less than 0. So I considered this 1 to 5 as the next interval. Similarly, if you go for other iteration, we'll be getting this. See, but I told you one thing, people are asking me. Here this epsilon I told greater than 0, correct? But in this question he is asking for exact solution. He is asking for epsilon is equal to 0. This equation doesn't get valid if you put 0, because to get this value of n, you need to apply logarithm, and log 0 is not defined. Okay, I told you e greater than 0 when I wrote this formula, but in this case e is exactly equal to 0. So there comes some change if you apply this formula, which is not correct actually. Okay, this e has to be some positive quantity, but it's 0 if you want the solution. So in 3 iterations you could get the solution, and this third iteration value is x is equal to 2, and f of 2 is equal to 0. Okay, straight away solving this question. I hope there is no discrepancy here for you. Okay, so can I go for next part? Clear? The real root of the equation 5x minus 2 cos x minus 1 is equal to 0 is dash. Here he is asking for root actually. F of x is equal to 0 implies 5x minus 2 cos x minus 1 is equal to 0. This is the equation. So we can apply Newton-raphson method, because that's the method which gives solution in less number of iterations. As we have seen, rate of convergence is high for that. So let us generate this iteration formula. Xk plus 1 is equal to xk minus f of xk. So 5xk minus 2 cos xk minus 1 divided by differentiation of this 5 plus 2 sin xk. This is what we have. Correct? Because derivative of this is 5 minus 2 into minus sin x. So this becomes plus. So if you simplify the things, xk plus 1 is equal to, if you multiply this 5 with here, this 5xk and 5xk gets cancelled. So 2 times of xk into sin xk minus into minus plus 2 cos xk minus into minus, again we have plus 1 divided by 5 plus 2 sin xk. This is the value that we have. So we need up to 2 decimals accuracy. So for this iteration formula we can perform calculations. 2xk into sin xk plus 2 cos xk plus 1 divided by 5 plus 2 sin xk. So initial guess is not given. So let us take some random guess because we don't know what's the solution. But for taking that random guess, we need to draw the graph first of all, because I told you if your initial guess is very close to the answer, if your initial guess is very close to the actual root of the equation, then your solution gets converged faster, correct? So if you make a random guess, your solution may take some more time to converge. But if you have some idea on the curves and if you can make an appropriate initial guess, then we can get things faster. Let us try to plot these two curves, which means 2 cos x is equal to 1 minus 5x, which is minus 5x plus 1. So y is equal to 1 minus 5x is one equation and y is equal to 2 cos x is another equation. Correct? So first of all, let us try to plot this straight line. Y is equal to 1 minus 5x. So if you put x is equal to 0, y value is 1. And if you put y is equal to 0, then x value is 1 by 5, somewhere here. So which means this line goes something like this, correct? Where this value is 1 by 5. Next, y is equal to 2 cos x. This value is actually 1. So 2 cos x means the line comes something like this from here. So if you see, something like this, but this intersects it here. Y is equal to 2 cos x, correct? Because this line will already decline when compared to this pi and all. So let us make x is equal to 0 as initial guess, because we don't know the exact value where it's meeting. So let x naught is equal to 0. If you have some idea, you can choose initial guess appropriately. If you don't have any idea, also you can make some random guess. Okay, but since we have some idea on graphs, we are going for that. This is pi by 2. Yes, this value is 2 because maximum value of cos x is 1, so this is 2. But it can decline like this again, correct? There can be a point of intersection to this line and this curve. So we will find that using calculator. So take initial guess x naught is equal to 0. If you don't have any idea of graphs, you can make some random guess. X naught is equal to 0 directly. X is equal to 0 is not a solution because if you put this equation doesn't get satisfied for x is equal to 0. Okay, you will get minus 3 is equal to 0. So please try to do this. X naught is equal to 0 initial guess. You have the iteration formula. So you can perform this Newton-raphson iteration scheme now. So initially if you calculate x1 is equal to, if you put x is equal to 0, this term is 0, 3 divided by 5, which is 0.6 is the first iteration value. X1 is equal to 0.6. Next, if you go for second iteration value, you can calculate, put x1 is equal to 0.6 in this equation. So please calculate this x2 value. Yes, you can consider Naga size 0 by default. Okay. Here also x0 is not mentioned in the question, but depending upon our knowledge in graphs, we have written something here. Okay. So let me calculate the value for x2. x1 is 0.6 when you have taken initial guess as 0, because 0 and 2 plus 1 is 3 divided by 5, which is 0.6. So let me calculate this whole value when xk is 0.6. Okay. So for doing that, see, I think many of your answers might be diverging, correct? Like 1 point, some 50, 40, some huge numbers. The mistake you are committing is in equations, if you have trigonometric ratios, please tell me this x here is in degrees or radian. Please tell me in trigonometric equations, will you take these angles in degrees or radians? Please tell me. In these calculations, in these equations, if you have trigonometric ratios like sin x and cos x, will you take this in radians or degrees? This is in radians, correct? So to perform this calculation, This 0.6 is radians, correct? Which means in your calculator, you should shift this radian button from degrees to radians. If you keep this button here and if you perform, your answers are wrong, because whatever you are substituting sine 0.6 degrees. Okay, but here we need to substitute in radians. We'll move this radian button, which is initially here, to radians. Now you can perform calculations. 2 into xk into sine xk. So sine of xk. Sine, see, if this button is in radians and if you click sine, you see sine radian of 0.6. Okay, this plus 2 into cos xk, correct? So 2 into 0.6 cos. So 2 into cos xk. Next, plus 1. Okay, so this is the value divided by what do we have? 5 plus 2 sin xk. Okay, so 5 plus 2 sin xk. Okay, so this is the value that is with us. 5 plus 2 sin radians of 6. This bracket closes for 2 and this bracket closes for 5, and that's the value. So 0.7494. 0.7494. So if you see, these two digits doesn't match here. Okay, so let us go for third iteration. X3 is equal to, now 0.7494 is the answer. So let us store this value first of all. So see, if I click ms, I got memory here. Okay, so next, 2 times of memory recall into, again for this memory recall we should apply sine. This is the value. Okay, so plus 5 times of 2 times of cos xk. So 2 times of cos xk as well. So 2 times of cos xk. 2 times of cos xk plus 1 divided by 5 plus 2 sin xk. 5 plus 2 sin xk. So if you see 0.54 table 7. 0.54 table 7. Okay, so 0.6. So I think I made some error. This typing didn't happen properly. So we need to calculate properly, and please carry out this calculation later when you are free. But this is how you need to take care of the things. Okay, you need to shift that to radians. That's the main thing I want to tell you at this moment. Okay, because if you retain this in degrees, your answers will change. Next, perform calculations whenever you are free and get the answer. Let us shift this back to degree and clear all the memory and cancel everything. Okay. So 0.543. Okay, so this is 0.543. Then what about this value x3? Okay, x2 is 0.543. Okay, so what about this x3? I think you should get 0.54 something here, which means if you draw the graphs correctly, you please calculate x3. Meanwhile, I will be trying to draw this graph correctly. Minus x, y, and this is minus y. So 2 cos x is equal to 5x minus 1 here. Sorry, 2 cos x is equal to 5x minus 1. 2 cos x is equal to 5x minus 1. So this curve is also y is equal to 5x minus 1 is one curve, and y is equal to 2 cos x is another curve. So 5 cos x, 5x minus 1. So if you put x is equal to 0, y value is minus 1. 0 comma minus 1. And if you put y is equal to 0, x value is 1 by 5. Okay. So this is 1 by 5 comma 0. Okay. So if you see, this straight line passes something like this. And y is equal to 2 cos x, as we discussed. If this is 2 and this 1 by 5 is less than 1 by 5 is equal to 0.2, but pi by 2 is 1.57, so it intersects something like this. This is x is equal to pi by 2, and this is y is equal to 2 cos x. Okay, so the answer is in between 0 and 1.57. So x3 is 0.5425. So if you see, he is asking up to till 2 decimal places. So 2 decimal places got matched, 0.54 and 0.54. So we say the answer is 0.54. Okay, 0.54. So this value is around 0.54. And that's why numerical methods involve a lot of calculations. They have developed calculators and all which operate on this principle, so which you can evaluate these values very easily. Okay. But if you use Taylor series expansion for this, generally, you know, you are neglecting higher order terms, correct? But you know, we don't know basically what is the h, what's the difference. Okay, here. So what will you take for h, Yugandhar? If you expand using Taylor series, for cos x, yes, I understand you use Taylor series. So if you understand 5x minus 2 into, I think this is what you are telling, x square by 2 factorial will take, but we'll neglect x power 4 by 4 factorial and all, and you are writing minus 1 is equal to 0. Correct? This is what you are telling to me. Okay. So, but if I take this, there is one complication. How would you decide without knowing x that this x cube by 3 factorial value is small? Okay. Here, since after doing some iterations, you know, the value is 0.6, 0.54 and all. Okay. So since x is less than 1, okay, then x cube by 3 factorial, if you neglect, then you need to solve 5x minus x square minus 1 is equal to 0, quadratic equation. But in exam, options will be given very closely, so I suggest to follow this. Okay, because final range will be given with 3% tolerance. Okay, so please solve this question. I think we spent a lot of question on that time because of the some big calculation that we involved with. So please try to solve this question, all of you. It's okay if you don't complete that question. It's just a calculation you can perform later when you got enough time to do that. So solution for this. Did you understand why can't we take approximations? Because we don't know what's the actual root. Okay. So suppose if root is, we know that root is less than 1, but if it's somewhere near 0.99 and all, then this term will still have some considerable good value. Okay, so we can't neglect higher order terms straight away in Taylor series. If you consider fourth power term, then you don't have any direct method to solve fourth degree equations. So better go this way. So please try to solve this question. It's a simple question and it's already 12:05. So 25 more minutes, we'll see what will happen during this time. So in a Newton-raphson method, an initial guess of x0 is equal to 2 is made and the sequence x0, x1, x2 and so on is obtained for the function 0.75 x cube minus 2x square minus 2x plus 4 is equal to 0. Consider the statements. x3 is equal to 0. Okay. The method converges to a solution in a finite number of iterations. So see here. Can we simplify this function as 3 by 4 x cube just to eliminate this 0.5? Nothing much, because having this 0.5 in the calculations could cause some trouble to us. So 3x cube minus 8x square minus 8x plus 16 is equal to 0. This is the equation for us. Correct? Both the equations are identical if you divide with 4. So if you see, we can frame this equation in this way by taking an LCM. So the equation is 3x cube minus 8x square minus 8x plus 16 is equal to 0. So if you start developing an iteration formula, xk plus 1 is equal to xk minus f of x k divided by f dash of xk, which is 9xk square minus 16xk minus 8. Correct? So this, if you simplify a bit, xk plus 1 is equal to 9xk cube minus 3xk cube. We have 6xk cube. Next, minus 16xk minus 16xk square plus 8xk square minus 8xk square minus 8xk plus 8xk. Xk terms gets cancelled plus 16. Sorry, minus 16 because of this minus sign here. So this is minus 16 divided by 9xk square minus 16xk minus 8. This is what we have for the iteration formula. So now, given x naught is equal to 2. So put x naught is equal to 2 and calculate this value. X naught is equal to 2. So x1 is equal to, so put x1, x naught is equal to 2. 6 into 2 cube, 8. 6 8 are 48. 48 minus 32. 16, 16 minus 16, 0. So x1 value is 0. Next, if x1 is equal to 0, what is x2? If you put 0 here, minus 16 divided by minus 8, 2. Correct? So if x2 is equal to 2, again, this is the value when you substituted x is equal to 2 in this equation. So again, if you substitute x is equal to 2, we'll be getting x3 is equal to 0. Which means, again, x4 will be 2 and x5 will be 0. So let us consider the two statements now. Two statements. So x3 is equal to 0. Yes, this is correct because we obtained x3 is equal to 0 here. Next, this method converges to a solution in finite number of iterations. No, this is wrong because you see this 0 and 2 keep on repeating alternatively, but they don't converge for a solution. Correct? So only one is correct and 2 is wrong. Because you have seen this iteration values keep on recurring as 0 and 2, but they don't converge to a finite solution. Okay, they just give you 0 and 2 alternatively. Correct, all of you. Jay, Kamaluddin, Neeraja. Okay, so all of you are correct, and this is option A. So we'll go for a few more questions. How many distinct values of x satisfy the equation sin x is equal to x by 2, where x is in radians? So please see, he's asking for number of solutions, but not for solutions. So try to plot and tell me the answer. Sin x is equal to x by 2. How many distinct values of x satisfies the equation sin x is equal to x by 2, where x is in radians? He's asking for number of solutions, but he's not asking for actual values of solution. Okay, of course, x is in radians, we know, because in all transcendental equations, x is in radians, which is a combination of trigonometric and other functions. So please tell me the answer for this. Three solutions. Okay, let me check. X 0 minus x, y and minus y. Okay. Now let us plot these two curves. First of all, y is equal to sin x. You know, in the first lecture of basic calculus, I told you how to plot y is equal to sin x. So the maximum limit is y is equal to 1 and the minimum value is also y is equal to minus 1. Correct? And you can plot sin x curve in between as, you know, things like this. For example, this is pi, this is 2 pi, and if you extend this, so this is minus pi by 2, and this value is minus pi. Correct? So this is the values that we have. This is pi by 2. Next, let us draw the line y is equal to x by 2. So you know y is equal to mx passes through origin. So y is equal to x by 2. Y is equal to x by 2. Correct? Now see carefully. This is one point of intersection. This is another point of intersection, and this is another point of intersection. So if you see, there are 3 points of intersections for this curve. Y is equal to x by 2 and y is equal to sin x. So we we here say that there are 3 values which satisfies this equation. Okay, so x is equal to 3 solutions. Clear? Did you all understand how I have done this graph? Please tell me. Around some 38 online, so please 36 something. So please tell me, did you all understand this? We have plotted y is equal to one function and y is equal to other function, and we have seen total number of intersection points. Okay, so clear? I'm moving ahead for next question. The number of solutions of x where x belongs to minus infinity to infinity. Okay, for the equation tan x is equal to x is k. This is equal to sign, so tan x is equal to x is k. Then the value of limit y tends to k y square plus 4 by 2y square plus 1 is dash. So please solve this. It's a simple question, I guess. So please try to solve this. The number of solutions of x where x tends to minus infinity to infinity for the equation tan x is equal to x is k. Then the value of this limit y tends to k y square plus 4 divided by 2y square plus 1. So first of all, to calculate this limit, we should know what is this k. Okay, so if you try to plot, see carefully. X minus x 0 13 by 19. Okay, let me see. Y and minus y. Correct? Now let us plot tan x graph first. To plot tan x graph, if this is x is equal to pi by 2, pi 3 pi by 2, 2 pi, and it can extend like this. Similarly, if you have minus pi by 2, minus pi, minus 3 pi by 2 and all. Correct? So see here. See carefully. Now, if you draw y is equal to tan x, look, I'll show you how does y is equal to tan x graph looks like. I told you already. Something like this. Correct? Similarly, if you continue here, we'll go from this particular point to this way. Correct? So they extends infinitely many loops. Now, if you draw y is equal to x here, y is equal to x, something like this. The line y is equal to x. Now, if you see the number of point of intersections of this curve, total are how many? What are the total number of point of intersections for this y is equal to tan x and x? Infinitely many. Okay, so my main intention is in this question I wanted to show number of solutions for the equation tan x is equal to x is infinite. See, on board you can see only some how many solutions you can see on board? 1 2 3 solutions. But practically what happens when this tan x gets extended like this? Again you will see one solution. Again in the next loop one more solution. So again in the next loop one more solution. So similarly, if this goes like this, you see this line coming and intersecting all these curves, which means this k tends to infinite. Okay, so now this is a simple limit. Limit y tends to infinity, y square plus 4 divided by 2y square plus 1. And now if you see, I told you when both these polynomials are of same degree, the ratio of the coefficients is the answer. So this is 1 by 2, which is 0.5. Okay, my main intention in this question is to show you that this equation tan x is equal to x has infinitely many solutions. That's the only thing. Okay, so once you know this, this is a very simple limit to calculate. Because if both the functions are of same degree, then I told you when y tends to infinity, we have ratio of the coefficients as the answer. So 1/2 is the answer, which is 0.5. Okay. Only one real root of f of x is equal to x power 6 minus x minus 1 lies in the interval 1 less than or equal to x less than or equal to 2. And bisection method is used to find its value. Okay. For achieving an accuracy of 0.001, the required minimum number of iterations is, see, now this epsilon is given, correct? Means the accuracy up to which you want is mentioned in this question. So now you can apply the formula I gave you for bisection methods. Solutions. So please see here. So minimum number of iterations that you need to have the accuracy of the iterative solution to be 0.001 accurate. So if you see, if you apply this formula, minus b by a modulus divided by 2 power n is less than or equal to epsilon. So if you see a comma b interval 1 comma 2, 1 less than or equal to x less than or equal to 2. So if you see, you can take interval as 1 comma 2. So if the interval is 1 comma 2, this b minus a value is 1 by 2 power n is less than or equal to 10 power minus 3, which is 0.001 can be written as 10 power minus 3. So if you bring this 2 power n to the other side and this 10 cube this side, 2 power n is greater than or equal to 10 cube, which by definition, 2 power 10 is 1024. So n value should be something like this. But if you still want n greater than or equal to log 10 cube to the base 2, so which is n greater than or equal to 3 into log 10 to the base 2. So we need to calculate that value, but by inspection, visual inspection, you can tell this n value will be 10. Minimum value of n should be 10, correct? Because if you put 2 power 9, then 512, which is for which this inequality that doesn't get satisfied. So if you see, then n should be greater than or equal to this. You can calculate this value. N is equal to 10, which by visual inspection you can tell, because when you put n is equal to 10, 1024 greater than or equal to 10 cube. Okay, and when you put 9, this doesn't get satisfied. So minimum number of iterations is 10. But if you want this value, you can calculate 3 into log 10 to the base 2. So see here, log 10. If you see log x to the base 2 is present here. So log x to the base 2, if you click here, this is the value. So into 3, 9.9657. 9.96, which means the minimum number of iterations that you need is 10 iterations. Okay, so minimum you need 10 iterations to have the accuracy of the root in bisection method for this equation with that interval to this accuracy, 0.001 accurate. Okay, so with that, the questions on transcendental equations got finished. So now we'll start system of linear equations. What's the time, by the way? 12:20. Okay. Okay, since there is 10 more minutes, we'll start the basic idea of system of equations. Solution of system of equation, linear equations basically. Okay, so solution of system of linear equations. We'll just give introduction. It's in 10 minutes for this. So see here, I'm dealing with 3 equations. So we'll be having 3 by 3 matrices and all. So see, if this is the system, a11x plus a12y plus a13z is equal to 0. B1 a21x plus a22y plus a23z is equal to B2, a31x plus a32y plus a33z is equal to B3. So if this is the case, then we have seen this equation can be written in the form Ax is equal to B in matrix form, where A is equal to A11, A12, A13, B11, B12, B13, C11, we made mistakes again. A11, A12, A13, basically the coefficients. So A21, A22, A23, and A31, A32, and A33, where X is equal to X, Y, Z, and B is equal to B1, B2, B3. Then, to find the system of equations, basically calculating this A inverse may not be feasible all the time, because calculating minus, then cofactors, then adjoint matrix, and then calculating A inverse by dividing with determinant, all these may not give accurate, may not be time saving for all the time. So we define one method here called, I'm straight away going to the methods. See, basically we'll discuss three methods: LU decomposition method, Gauss elimination method, and Gauss seidel method. So we'll discuss one of the methods today if time permits, the other also. So LU decomposition method. LU decomposition method. Okay, so in this we'll go for Doolittle algorithm. We'll see what is this Doolittle algorithm. So see here, we have Ax is equal to B. Correct? So the first thing that we do is write A as product of a lower triangular matrix and an upper triangular matrix. So we'll write this A as a product of this lower triangular into upper triangular matrix. So this implies L multiplied with U multiplied with X is equal to B. This is what you have in matrices form. Take U into X is equal to some Y, matrix Y. Then what we'll be having? Lower triangular matrix into Y is equal to B. And this will give Y for us. Okay, so we'll be evaluating Y because we will determine what are the elements of L, we know what are the elements of B, and this product will also be lower triangular, so we can identify what are Y elements. We have Ux is equal to Y, and this equation, if we know Y and if you know U, you can calculate L. So calculate X from this. Okay, so calculate X from this, and this X is the actual solution that you need. And of course, when defining this lower triangular matrix, we'll define something like, see here, L11, in Doolittle algorithm, we take the principal diagonal elements of the lower triangular matrix to be 1. So 1, 0, 0, L21, 1, 0, L31, L32, 0. So, 1. Okay, so this is how you will assume lower triangular matrix with all principal diagonal elements as 1. And this is a Doolittle's algorithm where you will be assuming this L as a lower triangular matrix with all principal diagonal elements equal to 1, and you have an upper triangular matrix. And finally, you will be following this procedure, with which I'll explain you one question, one example we'll solve now. So we'll understand all these steps in a sequence. Okay, so let us form one system of equations. Solve, let x is equal to 1, y is equal to 2, z is equal to 3, for example. So let us form one system. X plus y plus z is equal to 6. X minus y plus 2z is equal to 1 minus 2 is minus 1. Minus 1 plus 6 is 5. Correct? 1 minus 2 minus 1. Minus 1 plus 6, 5. So x minus 2y plus z. Another any equation randomly. 1 minus 4 minus 3 plus 3, 0. Okay. So this element is 0. X minus 2y plus z. 1 minus 4 minus 3 plus 3, 0. Okay. So this is the system of equations for which these are the values actually, because we formed this system using this. So now we'll convert this into matrix form. A is equal to 1, 1, 1, 1 minus 1, 2, 1 minus 2, 1. So if you see, first of all, let us make sure that this is not a scalar matrix. So minus 1 plus 4, 3, minus 1 into 1 minus 2, minus 1 plus 1 into minus 2 plus 1, this is minus 1. Okay, the answer is not 0, so fine, determinant is not 0. So see here, this is A, so x is equal to xyz and b is equal to 650. So this is how you can form a set of equation ax is equal to b. Now this A can be written as, in LU decomposition method, a product of a lower triangular matrix into an upper triangular matrix, correct? And if you are following this Doolittle algorithm, see, we have this lower triangular matrix as 1 0 0, L21 1 0, L31 L32 1, and this upper triangular matrix as U11 U12 U13 0 U22 U23 and 0 0 U23. Okay, see, out of these two matrices you have provision for putting this principal diagonal elements as 1 in any of the matrices, but in Doolittle algorithm we put this as 1. But even if you take this as L11 L22 L33 and if you replace these values with 1, your answers doesn't change, means the final solution of the system doesn't change. But in Doolittle's algorithm we'll replace this principal diagonal elements of this lower triangular matrix as 1 to simplify the calculations. That's it. Okay, so this implies A is equal to L into U, correct? So what is A? This matrix 1 1 1 1 minus 1 2 and 1 minus 2 1. This is the matrix. This is same as 1 0 0 L21 1 0 L31 L32 1 multiplied with U11 U12 U13 U21 U22 U23 and U31 U32 and 33. Okay, so these elements are zeros. All this is an upper triangular matrix, correct? So let us make these elements zeros. Okay, so this is an upper triangular matrix, so we'll make all the lower diagonal elements zeros. Now if you multiply, where Kamaluddin did something, acha, here. Okay, this is 33, which is known to us and we mentioned it correctly here. Okay, so see here carefully, 1 1 1 1 minus 2 2 1 minus 2 1. This is equal to, see carefully, let us multiply these two matrices now. If you multiply these two matrices, first element is U11, first or second column element is U12 and first or third column element is U13. Next, second or first column, so L21 U11 L21 U12 plus U22 L21 U13 plus U23. This is what we have. Next, coming to the last row, coming to the last row, L31 into U11. Next, L31 into U12 plus L32 into U22 plus, and this last element is L31 U13 plus L32 U23 plus U33. This is the matrix that we have, correct? So if this is the matrix that we have, if you equate the elements, we have U11 is equal to 1, U12 is equal to 1, U13 is equal to 1. Next, L21 into U11 is equal to 1. So U11 you have already as 1. So what about L21? L21 into U11, which is 1, is equal to 1. So L21 is also 1. Next, L21 into U12, L21 into U12, which is 1. So 1 plus U22 is equal to minus 2. So 1 plus U22 is equal to minus 2. So U22 is equal to minus 3. Next, L21 into U13, L21 into U13, which is 1. 1 plus U23 is equal to 2. So U23 is also 1. Next, we'll go for the other elements. L31 into U11 is 1. So L31 is also 1. Next, L31 into U12. L31 into U12 is 1. 1 into 1 is 1. 1 plus L32 into U22, which is minus 3, is equal to minus 2. So this implies L32 is equal to, if this minus 1 goes to the other side, we have minus 3. So minus 3 divided by minus 3, we have L32 as 1. Next, for the last part, L31 into U13, L31 into U13, which is 1, plus L32 into U23, L32 into U23, again we have 1, plus U33, this is equal to 1, which means U33 is equal to minus 1. So we got all the elements within this total matrices. So let us form the matrices now. A is equal to LU, and we have L into U into X is equal to B 6 5 0. So let us write the elements. U22 is minus 2. This is minus 2. Let me check. L21 into U12, which is 1 into 1. 1 plus U22 is equal to minus 2. 1 plus U22 is equal to minus 2. Then U22 is minus 3, right? Acha, this element itself I have copied on. So this is minus 1. If this is minus 1, then this value is also minus 1. If this value is minus 1, 1 plus U22 is equal to minus 1. So U22 is minus 2. Correct? So this U22 is minus 2. Okay. Then wherever I have used U22, things changes now. For this term you used U22. So if this term you use U22 here, L31 into U13 is 1. L31 into U12 is 1. 1 plus L32 into U22 is equal to minus 2. So this implies L32 is equal to minus 3 divided by minus 2. So L32 is 3 by 2. This is 3 by 2. Third, next, if L32 value changes, this last value also changes. So let me correct here also. So L31 into U13, which is 1, plus L32 into U23 is 1, plus U33 is equal to 1. So 1 gets cancelled. U33 is equal to minus 3 by 2. Okay. 3 by 2 or minus 3 by 2? Please tell me, Monica. Minus 3 by 2, correct? Yeah, I hope things are fine now. Minus 3 by 2. So now let us frame this matrices. We know all the principal diagonal elements of the lower triangular matrix are 0 and upper diagonal elements are also 0. So next, see here. So L21 1. So L21 is 1. Next, L31 1 and L32 is 3 by 2. 1 3 by 2. So this is 1 and this is 3 by 2. Next, U11 elements. You know, these two elements are, these three elements are zeros. So U11, U12, U13, all these are ones. So 1 1 1. Next, U22 and U23. U22 is minus 2 and U23 is 1. So minus 2 comma 1. So this is minus 2 comma 1 and this is minus 3 by 2. We got here. Correct? Now, what we are assuming now, see carefully. Once you write this LU decomposition, we'll take this U into X as Y. Correct? Means this U into X, we are taking this as Y, which means for this upper triangular matrix, when you multiply here, we'll write this as 1 0 0 1 1 0 1 3 by 2 1. We'll take this as Y. So Y1, Y2, Y3 means this product of UX, U into X, we are taking it as Y. And of course, you know, if this is of order 3 by 3 and if this is of order 3 by 1, you will be getting a 3 by 1 matrix. This is equal to 6 5 0. So let us do the things. Y1 is equal to 6. Y1 plus Y2 is equal to 5. y1 plus y2 is equal to 5, y1 plus 3 by 2 y2 plus y3 is equal to 0. This is what we have. So now if y1 is equal to 6, y2 is equal to minus 1. y2 is equal to minus 1, correct? So y1 plus 3 by 2 into minus 1 plus y3 is equal to 0. So y3 is equal to 3 by 2 minus 6, which is 3 minus 12 minus 9 divided by 2. So y3 is equal to yes, this is L and u into x is y. Correct? Things are going fine as of now? Please tell me, are things going fine now? Okay? Is everything okay? Please respond. Did we make any mistake here? Okay, so things are going fine. So y3 is equal to minus 9 by 2. So see here, u into x means 1 1 1 x 0 minus 2 1 y 0 0 0 0 minus 3 by 2. So u into x is equal to y, and what are the values of y1 y2 y3 we got here? 6 minus 1 minus 9 by 2. So let us calculate the things. You know, if you go from the, or else you write the equations, x plus y plus z is equal to 6, okay, minus 2y plus z is equal to minus 1, and minus 3 by 2 z is equal to minus 9 by 2. So if you see, 2 gets cancelled, this minus minus gets cancelled, and 3 cancels this 9 3 times. So z value is 3. Next, if you put z is equal to 3 in this equation, minus 2y plus 3 is equal to minus 1. So this is minus 4, y is equal to minus 2. Plus 2, because minus minus gets cancelled. So y is equal to plus 2. If you put y is equal to 2 and z is equal to 3 in this equation, you know x is equal to 1. So just by doing this LU decomposition, we can write this xyz values as 1, 2 and 3. Okay, which is the actual solution which we actually know here before starting the question, because we framed this set of equations using this x is equal to 1, y is equal to 2 and z is equal to 3. Okay, so here this is how we perform LU decomposition method for any of the given matrices. Now in exam, what they are asking, when you split this A into LU, what is this element, what is this element? So they'll ask for different elements. So we need to solve for this. Okay, so now there is one complication here. Before I would like to close this lecture in next 5 minutes, but please see here one important thing that you should make a note of. LU decomposition may fail sometimes. When? If this determinant is 0, means this det A is 0, if this determinant is 0, then A, you are writing it as L into U, correct? And if this is equal to 0, then we know if these are not 0 matrices, then both det L is same as det U is equal to 0. You remember, the product of two non-zero matrices is singular, then both the matrices are singular. We showed one result in linear algebra, if you remember, correct? If both x and y are non-zero matrices, but if product of xy is a scalar, singular matrix, then both x and y are singular matrices. We shown this result, if you remember, in linear algebra, correct? Then if det A is 0, then both of them will be 0, which means, you know, this LU decomposition method fails if any of these principal diagonal elements are 0. Okay, so if you get any principal diagonal element like u11, u22, u33 is 0, then you know this total determinant value goes to 0, and then this method fails. So to avoid that, means when you are evaluating LU decomposition method, if you are getting any of the principal diagonal elements 0, this is 2 here, right? So see carefully, while calculating LU decomposition method, if you are getting any principal diagonal elements 0, then just do one thing, swap these equations and again perform LU decomposition. Okay, if you are getting, or if you are restricted by this LU matrices at any point with having principal diagonal elements as 0, then just you can do one thing, you can swap these equations. You know, if I write this in this order, if I shift the first two equations, both are same, correct? it's again gives the same system of equations. So we can swap the equations and we can calculate the values. Okay, so it's already 12:40. Okay, so we'll stop here for this moment and we'll meet tomorrow at 7:45. Okay, so we'll meet tomorrow. Thank you all. Have a nice time.